All right, 2.1. So 2.1 is talking about frequency distributions. And what does a frequency distribution actually look like? So what we have here is, say, here's a list of some data that we obtained from, I'm not actually sure. You guys can read through the top if you want to. But let's say, actually, this is kind of important. We know Flint, Michigan had a problem with their water supply, and we poisoned lots of people with lead. So what this is this is scores of lead that has been sampled in people. So this is the low lead group, and this is the high lead group. But the idea is what we can do is we can sample data, and we can actually get numbers from this particular data. So let's just say we're doing this low lead level group right here in group 1. Do you notice that if you look at this data, that it's really hard to pull any information from that data, because it's kind of all over the board. So what we want to do is we want to come up with some kind of organizational scheme, like how many people are in a particular part of this group. So one way we can actually do this is we can group it by maybe like tens, or group it by 5. So I can take like group of the 70s, group of the 80s, group of the 90s, group of the hundreds, and then so on. So when we look at those groups, what we've done is this right here is that frequency distribution of that particular sample. So the way they did this is they looked through there and they said, okay, well, I'm going to go from 50. Actually, they didn't go by 10s; they went by 20s. So this is the 50s and the 60s. So and you might want to say, like, how is that 20s? Well, 50s and 60s actually represent 20s. So if you're looking at how big this size is, what you're actually looking at is you actually subtract 70 from 50. So really, these classes are size 20. So the way they did that is they went to the state and they said, well, how many of them are 50? So they counted 2 of them. And they asked how many are 50 through 69. And then they went through 70 through 89. They looked like, okay, 1, 2, so they went 1, 2, 3, 4, 5. So what they're doing is I'm just making a count of how many are in the 70s or how many 80s, and there are 33 of those particular. 35 in between 90 and 109, 7 in between 110 and 129, and 130 between the other ones. So this is more of an organizational scheme that would be useful to us. Now I can actually kind of make some observations about this. Like, I noticed that most of the people are in the 70s, and the 80s, or the 90s, and the all the way to 110, 109. The hundreds through just below 110. So what we have to do is we have to come up with some definitions for what this frequency distribution actually represents and how to look at the edges. So what we have is we have lower class limits. Well, the lower class limits happen to be these pieces right here. So let me zoom out a little bit. So if I want lower class limits, this is the smallest numbers that can belong to the different classes. So 50 is a lower class limit for the first class, 70 is a lower class limit, 90 is a lower class limit, 110. So those 5 things are what you consider the lower class limits. So then the upper class limits are these. Your 69 is the upper class limit for the first class, 89 is the upper class limit for the second class, and then so on. The class boundaries are actually the real numbers that separate these two things. Now, we know that we're only getting integer values, so what I need what's the separation between the 70 and the 69. So if you want to find the class limits, what you do is you average those. So in 2.1, what we do is if I want to find the class boundaries, what I'm going to do is there's a one right before this because there's a boundary between 50, but we'll have to find some pattern. So this is 60 plus 70 divided by 2. So what we're going to see is this is 69.5. The next one is going to be, I'd average these two, this 89 plus 109 divided by 2. So we need notice that we're going to get is, is that right? That's not right, I apologize. So it's 89 and 90. So 89, and this should be 90. Divided by 2, so this is 89.5, and so on. So what we can see is this goes by 20, so 69, 89, 109.5, you can see that would be the class boundary for this 109, this is 129.5, and then even this 149 has a class boundary, 149.5, and then before the 50 also has a class boundary, so this would be 49.5. So when you guys are finding the class boundaries, don't forget about the first and the last one, okay? So notice 1, 2, 3, 4, 5, 6. Your class boundaries have 6 points, as opposed to your upper and lower class limits, which only have 5. 1, 2, 3, 4, 5, and so on. Class midpoints. Well, in order to find the midpoints, what we can do is just average the upper and the lower, or you could even average the boundaries. This would work as well. But if you want to find the class midpoints, what we do is we can average the lower class limit, the upper class limit. So 50 plus 69 divided by 2. The other one would be 70 plus 89 divided by 2. And then so on. So when we figure these out, so I need to be careful you guys understand how to do this. So of course this would be 59.5, and then the next one is going to be 79.5. So when we calculate these things, let's make sure you guys understand. Like, if you do 50 plus 69 and then hit divided by 2, you're actually not getting the correct answer. You're only doing 50 plus 69 divided by 2. So one way to do this is you can do 50 plus 69 and then divide by 2 seconds. Hope you can't even see that. My bad. So what I was saying is you can't do it this way, 50 plus 69 divided by 2, because you're doing 59 plus 50 plus 69 halves. You want to divide the entire thing by 2. So one way you go 50 plus 69, enter, and then you go divide by 2 seconds and enter. Or you can put the top in parentheses and then divide by 2, and that'll give you a correct answer. So that's how we're getting this. So 59, 79, and 99.5. The other one is going to be plus 20. 79.5, no, 19.5, 139.5, and that's going to be 139.5. So those things right there, these are going to be your midpoint. So just average the lower and the upper, average the lower and upper, average the lower, upper, and so on. So you're going to get your 5 to hit as well. Class width. The way you find class width, and you have to be careful here, because if you look at this, you might think that class width is 19, which would be incorrect. The way you find your class width is you either subtract consecutive lower bounds or consecutive upper bounds. So our class width would be 70 minus 50, which is equal to 20. And actually, if you look at all these data points, you'll notice that each one of these things are separated by 20 units. Even if you look at the lowers, they're all separated by 20. The upper, they're all separated by 20. So all these things are separated by this 20 units. So that's our class width right there. So be careful when we do x-axis. So eventually we're going to do some histograms. So what I want you guys to use for the histograms is I want you guys to use the boundaries. Okay, I want you guys to use the boundaries, and I'll talk about that when I get to graphing. And that'll be it for that section. Like I said, read the sections. I'm only doing the main focus of each of this in these particular videos.